Welcome everybody to today's Vision Energy webinar on storage-based transmission and distribution solutions. My name is Matt Barber with Mercom Capital Group, and I'll be the moderator for today's session, and we'll introduce our expert presenter. First of all, just some real quick housekeeping. Your microphone is not broken. We do have all attendees on mute just to make sure that you can hear the presenter clearly. Please feel free to ask questions using the panel on your toolbar. Just type them in anytime during the session, but note that we won't be answering them until the end of the presentation. We are also recording today's webinar, and we will send out a link to all registrants after we are done. Today's expert presenter is Vision Energy's Vice President of Marketing, Mike Renaud. Mike has over 15 years of experience with businesses that are focused on deploying clean technology with companies such as General Electric, Trina Solar, Moventus, and now Vision Energy. So everybody, you're in for a real treat because Mike really knows his stuff. Mike, take it away.
Well, Matt, I hope you didn't oversell it, but again, I want to thank everybody for joining. If you're here for this hour, I hope that we can have a good discussion about Vision, our products, our technologies, our solutions, why they're different, better, and specifically spend most of our time looking at transmission and distribution applications for energy storage. Primarily in North America, the markets for deploying energy storage in the front of the meter have been single-use case power applications in territories like PJM. And as we look at the trajectory for all-in turnkey system costs for energy storage, and we pair that up with the already super aggressive cost decline with renewable energy, we have the making for some pretty incredible front of the meter applications. Now, each one of these applications will essentially hit its stride based on the economics of the territory, based on the economics of the specific use case. But I want to just go over these today and plant the seeds in your minds for what can happen and what we at Vision believe will happen in the future. For those of you who have never seen a Vision flow battery before, what you're looking at here is a 200 kilowatt 4-hour battery. It's a 40-foot shipping container on top of a 53-foot shipping container. In the bottom shipping container, you have 2 large tanks. In the top shipping container, you have 12 stacks. That's a 200 kilowatt unit. You stack 5 of them up in a row like you have in the upper right-hand corner. That's a 1 megawatt 4-hour battery. It's about the size of a tennis court, an overall footprint within the fence around the tennis court, not just the lines. It is 12 stacks, each around 20 kilowatts. There are no moving parts except for the pumps. We've been commercializing this technology at Vision for 8 years. The shipping for 2 years. It is a highly versatile system. It scales anywhere from 100 kilowatts to 100 megawatts, and we're actively making deliveries today. Everything we make is made at Jabil. They're a ISO 9001 certified contract manufacturer. They're one of the top 3 contract manufacturers in the world with over 100 locations globally. Everything that we make is delivered by Jabil, and in order to win, our first 10 to 15 projects, we've had to undergo a lot of external scrutiny by, third parties that are known well around the world, like TUV in Germany and Black & Veatch in North America. And we're pretty proud of the awards that we've received, and they're really helping us gain adoption and gain traction and win market share with specific customers and partners that we're very proud of. We're actively manufacturing and delivering the largest flow battery in North America, and we're getting ready to announce a similar project in Europe. We're very pleased with our partnerships with Schneider on the balance of system side for PCS and controls. We'll talk a little bit about that next. And then our EPC partners who are there to give customers turnkey quotes when they need them, because we sell part of the system and we're here to deliver whole solutions. A lot of you might recognize this chart. GreenTech Media came out with this in 2016, and I've added the checkboxes. I've done that because it's a nice way of looking at front of the meter and behind the meter applications by color code, but also by discharge duration and frequency of use. It's a new filter of looking at sort of the old power versus energy discharge duration chart we're all used to seeing. The very unique thing about Vision is that from a single platform, we are able to deliver both long duration energy services, we call that walking, and short duration power service, we call that chewing gum. So the ability from one energy storage platform to deliver energy services and power services is very unique, and we'll talk a little bit about that and how it applies to transmission and distribution applications going forward. Talked a little bit about Jabil, but more detail. 50-year-old company, $20 billion in revenue, 100 locations, ISO 9001. Everything we produce is sourced and assembled by Jabil. We're very excited about the partnership. A little more on Schneider. What you're looking at here are pictures of a 1 megawatt Schneider inverter located in our engineering facility right next to one of our GS200 products. These things are hardwired together. We are collaborating actively, regularly, to make sure that we eliminate one of the biggest risks, which is the communication between the battery, the controls, and the PCS. And so, our partnership brings systems to market that essentially eradicate startup and commissioning and integration risk. Just about every utility or developer or IPP we speak to, after they get a sense for why we're different and how it works and how the economics are going to pencil out, they always ask us for a turnkey quote. And it's critical for us to bring in EPCs who have significant experience deploying large power generation equipment. And Ryan and Alpha are basically our partners for turnkey bids here in North America. One of the reasons why customers who are essentially looking at different storage options tend to gravitate and get interested by the Vision offering is because of how our performance is manifested in our warranty and how that compares to similar warranties from tier 1 leading lithium-ion suppliers. So whether it's state of charge, cell temperature, accumulated energy, or average charge and discharge power, the Vision system and the Vision offer doesn't put limits or penalties. It doesn't build those into the warranty. Quote down below from a controls company executive comes out and says that 85% of lithium-ion battery controls code is dedicated to protecting the battery from itself. And what we find when we talk to the same controls engineers, when they're building controls for Vision systems, basically they're using 1/10 of the number of lines of code because it's such a simple system to operate and it doesn't have all these trapdoors. I promise this is the last slide on Vision, and then we'll get into transmission and distribution. But when you compare Vision to a lithium-ion system, it's a 20-year system. It's got the same engineered and manufactured warranted lifetime as your solar panels or your wind turbines versus a 7 to 10-year system on the lithium-ion side. Like I said earlier, from one platform, power and energy applications, as opposed to lithium-ion, where you basically have to pick either or. It's safe and non-toxic chemistry, allows you to easily permit, site it, and execute projects. Then the fact that it has no AC loads. We're actively deploying projects into super hot climates, and we don't have the auxiliary loads that are required to maintain cell temperature, state of charge, regardless of the duty cycle. So there it ends the Vision portion of the presentation, and I got through that in 7 or 8 minutes, and I apologize if it was a little long-winded. Transitioning into the portion of the discussion that's focused on transmission and distribution, the vertical red dashed line here kind of delineates the front of the meter to behind the meter line. And today's presentation is going to focus on storage applications to the right of that line in low, medium voltage, and storage co-located with non-dispatchable renewable energy. I'm speaking to utilities daily, and utilities come in all shapes and forms, whether they're co-ops or munis or merchant transcos or members of various ISOs and publicly regulated utilities. And whether it's coal decommissioning, nukes being phased out, the promise of an incremental 150 gigawatts of wind and solar here in North America, coming in at price points that were heretofore not expected. All the DERs coming online, right? I mean, all of the distributed solar, all of the distributed batteries, electric vehicles, load growth uncertainty, significantly creating a lot of unknowns for specific utilities. The question that we get all the time is, how do we future-proof decisions on 20-year assets? And specifically as it pertains to storage, how do we make sure that this energy storage system is going to be flexible and durable for 20 years? If you look at the global forecast for new spending on transmission and distribution hardware, basically in 2017, it's estimated to be between 160 and 180 billion, with an 11% growth rate and a 14-year spend of 1.5 to 2 trillion dollars. Now, as a battery guy, my biggest issue with that is that 40% of the grid is only used 10% of the time. The grid itself is sized for peak load. And many of the new transmission lines we're putting in to bring, renewable energy from the place where the resource is rich to the place where there is demand, many of those transmission lines are underutilized. And so storage has a major role to play in transmission and distribution markets, and we'll look at those applications in the following slides. Some of you have seen this chart before, some of you haven't. What we've done here is looked at a study that was done by the DOE not too long ago, and they went ahead and they sized the market potential based on the number of hours available in storage. So you can see on the x-axis here, it goes from 1 second to minute to hour to 2 hours, all the way up to 10 plus hours. And you're looking at some applications that we'll be discussing, whether it's time shift, load following, reserve capacity, T&D upgrade deferral, transmission and congestion relief, renewable energy time shift and capacity firming, and wind and solar integration. What you will notice is that the lion's share of the total addressable market, which globally is over $600 billion, is between 2 and 7 hours, right? With major spikes happening at 3 and major drop-offs happening after 6. Now, we're all familiar with PJM frequency regulation market. That little red dot there, and frankly, I couldn't find a pixel small enough, is what some have described as a pre-market niche, right? Frequency regulation, in my opinion, isn't really storage. It just happens to be something that lithium-ion batteries can do, right? And they happen to be storage devices. And so oscillating around a point, providing voltage up, voltage down, frequency up, frequency down, is a key thing our grid requires, but it's a small piece of a short duration market. And frankly, as I said earlier, what you're really going to want your energy storage systems to do is to be able to walk and chew gum. Chewing gum being the ancillary services, the high power ancillary services, walking being the longer duration energy services out of a single platform. This chart is pretty popular. I see it everywhere I go. Got to thank Amory Lovins and the guys at RMI for pulling this together. The purpose of this chart looks at the various services that storage can provide, from centralized to distributed. Today on this call, we're going to be focused on these utility services down here, specifically transmission congestion relief, transmission deferral, distribution deferral, and renewable energy integration. And I want to just plant the seed that, those types of services, fall generally into the basket of walking, right? Those are energy services. And the fact of the matter is that those type of services in most grids and most applications are used way less than 100 days a year, because there are that many days of year when the transmission and distribution system is essentially operating at or near peak capacity. The rest of the year, you're looking at spinning reserve, frequency regulation, voltage support. These are power applications. This is kind of going back to the chewing gum analogy. Even on the same day, these systems can be used for transmission and distribution deferral and frequency regulation from a single point of interconnect. In speaking with utilities, right, and looking at the way transmission is being planned, transmission upgrades are typically planned anywhere from 3 to 10 years in advance based on expected load growth, needs of the system, overall reliability, and the dollar amounts that are getting rate-based or flowed back through the rate structure are significant. Frankly, I look at that as a pretty big risk. Like, what happens if the load growth or the forecasts don't come true? Whether it's vision or it's another storage technology, I think we need to have a change in how we're thinking about planning, because storage allows you to have a granular rollout and a smooth capital spending profile, and it reduces the risk that basically the trends, the energy demand trends or the load growth trends that got you into transmission planning and investing in significant new infrastructure don't come to fruition. So whether it's, Texas wind or Southwest power or Great Plains and Midwestern wind, these maps on the left are pretty interesting. It's not the red state, blue state, but it's where is it windy and where is it sunny? And we all know that, these resources are pretty far from most population centers. And as we look at building new transmission to get clean energy to load centers, there's only going to be a finite amount of transmission. And we want to make sure that we're using those lines at or near 90% capacity. Just recently, this Northern Pass line was approved, a $1.6 billion investment to get Quebec wind into New Hampshire. And, those types of investments are significant. And, wind farms themselves have anywhere from a 35 to a 45% capacity factor. Solar farms have anywhere from a 17 to 26% capacity factor. So I want to challenge us to start thinking about systems that we are engineering with our EPC partners, where you could attempt to put, let's say 100 megawatts of solar and 50 megawatts of energy storage on a single interconnection point and never dispatch more than 50 megawatts, but have a 40 to 45% capacity factor out of a solar farm. Another good example of that is the Sunrise Power Link, Imperial County. Here's a picture of it. It runs from the Imperial Valley substation all the way to the Sycamore Valley substation in San Diego. At its peak, it can carry 7 gigawatts of solar, 3 gigawatts of wind to support 8 million homes. Looking at it, if it's fully loaded with solar, it's about a 30% capacity factor, and that's only 2.7 million homes. So at $1.9 billion of cost, to maximize the resource, we have to start thinking about how we take these non-dispatchable, intermittent forms of renewable energy and turn them into dispatchable forms of renewable energy that can meet the needs and match the profile of the demand. Not to take you too far out of the country, but I don't know if you guys have been following India. India currently has 180 gigawatts of total grid capacity, and they've announced that they're going to put 160 gigawatts of distributed and utility scale wind and solar. Now, that's just, like trying to pack, twice as many cars on a road. And, the fact of the matter is they're going to need either a massive investment in new transmission and distribution to make sure that all these systems aren't curtailed, or they're going to have to take an approach with these non-dispatchable renewable energy sources to essentially integrate them better into the grid, to drive dedicated T&D capacity utilization up over 90%, and they have an opportunity here to reduce their T&D infrastructure upgrades by over 2x. So there's currently between 60 and 70 gigawatts of wind installed in the North American grid. And if you look at the spaghetti bowl in the lower left-hand corner of this chart, you can see that the capacity factors of these farms vary drastically across a single ISO based on the independent wind signature of that region. Now, if you squint your eyes, you could imagine a single constant line. But for a load balancing authority, this becomes a significant challenge of wind integration and matching it up with dispatchable, throttleable thermal assets to essentially allow the system to give reliable power that meets the needs of the end customer. So whether it's integration on-site or off-site at a nearby substation, the ability to control intermittency, ramp rate control, while simultaneously providing grid support through voltage and VAR support and eliminating curtailment is a huge opportunity to build a cleaner and more efficient grid that maximizes the use of very low cost clean energy in the future. In addition, and this isn't true everywhere, but we've all heard the anecdotes of wind blowing at night, right? So energy storage can take night wind and turn it into day power. This is a similar story, but it's a little different. We just talked about utility scale wind. I'm talking now about utility scale solar. This idea of taking a 100 megawatt solar farm and interconnecting it on a 50 megawatt interconnect is interesting to utilities. It's also interesting to developers. What I hear from developers is that right now the largest development risk for utility scale solar is actually finding a decent interconnect. And land is no longer the challenge. It's essentially managing their place in the queue. Every developer out there has, let's just say, 100 queue positions and only hopes to build 10 to 15 farms because there are limited space that folks would call low-hanging fruit in terms of obtaining grid interconnection for utility scale solar. And so the utilities and the off-takers love the idea of getting afternoon power, and the developers love the idea of being able to put more DC power and double the capacity factor almost of a utility scale solar plant on a smaller fixed interconnect. In addition, this is not just an energy service, right? So a lot of times folks look at utility scale solar, and you can see here the blue curve and then these spikes, right? The spikes in the solar output are what's called cloud chop, right? Cloud chop mitigation, or cloud chop is basically driven by spots of clouds coming over portions of the solar site. And it can get very volatile, and the plant can ramp anywhere from 30 to 100% within seconds. And integrating that into a grid is very challenging in terms of load balancing and power quality. And when we look at what a battery should do in a utility scale solar installation, you want it to be able to do the 3 to 6 hour energy service, but you also want it to be able to do that instantaneous power service. And as we talked about earlier, and this is a shameless plug, with Vision Systems, you have the versatility to do, the walking and chewing gum, the energy and the power services, as opposed to lithium-ion, where you kind of have to engineer the system around one or the other. we just talked about Cloud Shop, but this is kind of a great example, right? You can see the picture of the system on your left. It's all doom and gloom, but just look at what happens to a system throughout the day. It's not that normal bell curve that we're all used to seeing throughout the day. This is what systems actually tend to do, when they're out there in the field. And these types of highly volatile outputs in plant performance from a large solar field create a lot of havoc on the grid. So now imagine a solar farm which, despite the resource, can give a constant output and can even take large blocks of power and contract those into 2 to 4 hour capacity markets in the afternoon and get a premium for it. The grid savings could be significant. In addition, that wind farm or that solar farm that has the storage capacity, when the wind isn't blowing or the sun isn't shining, it can participate in ISO and high frequency services like frequency regulation and volt var support. This came out of a recent study in ERCOT. ERCOT forecasted that by 2031, 20 to 30 gigawatts of coal inside their territory will be replaced by solar. These are their numbers, these are their charts, right? And it leads to the graph on the right. And the graph on the right shows the resultant gap, the 3 to 4 hour gap at 18 gigawatts for energy storage to meet the needs of the load base, because the wind hasn't started yet and the sun is done shining. For those of you with any experience with munis and cooperative utilities, this slide's going to be interesting. For those of you who don't know, munis and cooperative utilities are all structured as nonprofits. Most of the time, they own their transmission and distribution networks down to their residential customer bases and industrial customer bases. They buy their power and they pay demand charges. So, a big storage market in California is commercial and industrial demand charge reduction. Well, it turns out that munis and co-ops also pay demand charges, and they typically own their substation. And those substations can or can't be reaching the end of their useful life. And a lot of times, there's an expectation for when that substation is no longer going to be able to meet its capacity due to load growth. And, frankly, these entities can't monetize the tax credit. And we're seeing our partner developers go after munis and co-ops and walking in and offering a solution that provides them with locally sourced solar or wind at below the rates they're paying for power. We're setting up the storage systems to be able to eliminate the demand charges. And we are building the systems on substations that are at or near the end of their capacity. And so, we're basically extending the life of these substations while we provide ancillary services to that distribution territory. It's a pretty unique solution. There are almost 3,000 co-ops and munis out there, and for folks who are interested in that, feel free to contact us over the call. At the end of the call, we'd be happy to kind of walk you through that solution and teach you how to sell it. Has anybody ever seen these wires on the left? These strange things, these single wires that run through most of the electrified territory in North America? They're called single wire earth return feeder lines. So instead of having a coupled pair of feeder lines, they basically use a single wire to transmit voltage and current over very long distances for rural electrification. They're typically anywhere from 50 to hundreds of miles long. They were built anywhere from 15 to 40 years ago. The poles are wooden, and the challenge you have is that as the load at the end of the line grows, you have a voltage drop and other power quality problems. And so you have a choice, really. if you want to go back and upgrade and hang a second line on these to increase the capacity, and there's a cost, right? And so what we're seeing is that utilities can achieve the same improvement in power quality and voltage for a fraction of the cost, depending on the length and the age of the line. So this isn't the sexiest of applications, but it's one actually where energy storage system can come in at a fraction of the cost of the alternative. So I'm nearing the end of my presentation, and in summation, transmission and distribution can provide really critical anchor benefits, right, in terms of life extension and T&D deferrals. However, those typically only apply during the periods of the year when the grid itself is kind of at its maximum stress point. And we know that only happens less than 100% of the year. Less than 100 days out of the year, and sometimes less than 10% out of the year. The rest of the year, these energy storage systems have an opportunity to provide significant value for their owners, whether it's supply reserve, congestion relief, increased renewable energy penetration, increased electric service reliability and power quality, and end user and co-op electricity bill management. So if there's one thing you take away from this call, please, I hope that it's that it is absolutely critical to look at the versatility of the storage system and its ability to provide, I'm sorry if I'm doing this for the third time, but these long duration energy services as well as these short duration power services from a single platform. That's sort of the walking and chewing gum analogy. This is our last slide. I'm not going to read every word on it, but performance, safety, and value, it's kind of the keystone of what we're doing. You got my email there. If you want to send me additional requests for information, we've got an excellent applications engineering team which can size your battery, size the renewable energy, and then we can pull in a number of partners to give you turnkey estimates for all-in system costs, and we can go from there. All right, Q&A. I'm reading the questions. And question number one, is Vision's electrolyte chemistry safe? And I would say that it's the safest chemistry available on the market. You can easily deploy our systems near high-value grid infrastructure because it runs on a safe chemistry that is non-toxic, non-flammable, and non-explosive. It's easy to recycle at the end of the life. These batteries, they ship dry, right? So the tanks on the bottom that you can see on this current slide, they ship empty. And when they get to the site, we have an installation team that will show up and they will commission the system. They use locally sourced water as the primary ingredient, then some KOH, and then 2 big bags of white powder. One of them is white powdered zinc, which is globally available and relatively inexpensive. And then the other is what's known as yellow prussiate of soda. And if you look on the back of Morton Salt, those round blue salt shakers that have the girl with the yellow umbrella, if you look on the back and you look at the ingredients, it'll say salt and yellow prussiate of soda, right? And so, the overall chemistry itself, is quite benign, and we don't recommend doing this, but in some counties in the United States, it's legally sewerable, right? And it's a particularly interesting combination. What kind of warranty coverage does Vision system have? So we're pretty excited about our warranty program, right? And I think I'll go back here to a much earlier slide. This one. Vision systems come with the base warranty that covers all parts and maintenance for 5 years. We do not limit our customers based on, access to state of charge, ambient temperature range, life cycle limitations, and we also offer an optional guarantee where we say that anywhere from 5 to 20 years, we guarantee that the nameplate power rating of the system will never go below 95% of its original rated value. That's a big deal. It's a big deal because most lithium-ion systems are oversized by 40 to 50% to take into account the expected degradation of 30 to 40% in the first 10 years. And most 20-year lithium-ion total cost of ownership calculations require a wholesale battery changeout once or twice over the course of 20 years. Now, the economics of lithium-ion batteries are declining, but what we find is that when customers look at not just the first cost, but the total cost of ownership, the unlevered project IRR of first cost, O&M, and maintenance, that we tend to have anywhere from a 200 to a 500 basis point advantage in unlevered IRR. This next question is in and around all-in system costs behind the meter for C&I install. So what I would ask anybody to do, and I'll go back to the slide where sorry. You may have lost my audio, but I'll go back to the slide with my email. One moment. There it is. The all-in turnkey costs of our systems tend to be within 5 to 10% on the first cost basis of lithium-ion for a 4-hour solution. The overall all-in turnkey costs tend to vary based on the overall size of the system, whether it's 100 kilowatts to 50 megawatts. And we have a process internally where we are able to quite easily and quite quickly give you a first order estimate for all-in system turnkey costs based on your loads, whether they're in front of the meter or behind the meter. And I ask you to reach out to me. I'll connect you with our application engineering team, and we should be able to support that request within 2 to 3 business days. So there are several other questions in here, but frankly, they look like they're repetitive. I would ask anybody on the call with additional questions to follow up with me directly at the email on the screen. And I look forward to hearing from you. And thank you very much for attending today. Have a great day.